Okay, let us start with the binomial distribution. As we discussed previously in the first part of the binomial distribution, we discussed the Bernoulli test, and at that time we understand from that part of this chapter that we have a success and failure probabilities, and as you understand that P plus Q equal to 1. And from that thing, we can predict the probability that we are aiming to find. But if you return back to the example that contains a result of 10 at that example, now we do need to understand or to take a shortcut for obtaining that 10 immediately without going in complicated things. Now we'll go directly to the binomial distribution by using large sample procedure and using of what we call the combination. Now if we go, a combination here of an object take x at a time is an unordered subset of x of the n object. This is the main definition of the combination. It is an ordered subset of x of the n object. As you see here, assuming n object, and Sx is the subset of the combination. Now, the number of combinations can be formed by this equation. N, as you see from this equation, we have n Cx. It can be termed as n combination x equal to n factorial over x factorial times n minus x factorial. So as you see from here, x is referred to, can be read as x factorial, that is the product of all the whole number from x down to 1. So we do need to understand this thing. It should be read as x factorial, that is the product of all the whole numbers from x down to 1. Now, down to 1, what does it mean? If you are referring to x factorial in this equation, the last equation, you can see x factorial is equal to x times x minus 1 times x minus 2 times x minus 3 times x minus 2 times x minus 1. This is the factorial. بمعنى آخر in Arabic we can call it مضروب العدد. If you return back to the secondary school lectures. So we have an example here. The example we take previously about the birth record. You do need to return back to the previous part of this chapter that talking about Bernoulli. In that example, we have n were equal to 5. N equal to 5. We are interested in finding the probability that 3 of them will be for male births. Please return back to the example. The number of sequences in our example is found by the previous equation. X equal to 3, which is the number of success. So the number of failure here is n minus 1. That equal to 2. Number of failure is 2. So if we solve it by using the combination equation, 5 combination 3, this is n combination x. So we have 5 is n, the number 5 is n, and 3 is x. C here refer to the combination, equal to x factorial, n factorial over x factorial times 5 minus 3 factorial. And this is the main example. How can we solve the combinations? Combination down to 1. So factorial, 5 factorial is equal 5 multiplied by 4 times 3 times 2 times 1. This is the factorial of number 5 that yielded 120. Now we do need to solve the denominator. which is 3 factorial, that yielded 3 times 2 times 1, multiplied by those numbers by subtracting 5 minus 3 from 3, sorry, that yielded 2, and 2 factorial is 2 times 1. So the total or the final result will be 10. If you return back to the previous part of this lecture, you will find that n is equal to 10, and we have a shortcut for finding this result by using the combination or factorial equation. Now we can obtain the x success in n trials as, now we return back to this equation, the x. Now we do need to find the x. Now we find it like this, okay? So we can obtain the x success in n trials as this, the fx here, which is the success, equal to n combination multiplied by q to the power or exponent to minus or n minus 1 times p to the power of x. And finally, by using this, by restructuring this equation, we can, the final formula is n combination x multiplied by p over x, okay, x over p times q to the power of n minus x, for x equal to 0, 1, 2 up to n number used in this, used in any example actually. Now we have the binomial distribution. This binomial distribution, by obtaining the x success or the failure, the probability of the number of success, if we have 0 success here, the number we will just only add x's here, n combination x will be 0. If the number of success is 0, the n combination 0 multiplied by q of n minus 0, because 0 here is the x, times b to the power of 0. If the number of success equal to 1, so the probability of the success will be n combination 1, because 1 here is the number of success, q to the power of n minus 1 multiplied by 1 to the power of 1 right here. If the number of success 2, just only add 2 instead of x in the main equation and you will yield the probability. Now you can find that from this table, the summation of all yielded probabilities for a certain action or events, okay, will yield 1. From this thing, we can conclude that the fx should be greater than or equal to 0 for all real values of x, and also the summation of all x's, fx's, should be equal to 1. This is the main characteristics of the probability distribution used in this, for the probability distribution used in this lecture. So, I have an example here. Suppose that it's known that 30%, now concentrate with me, 30% of a certain population are immune to some disease. If a random sample of a size 10 selected from this population, what's the probability that it will contain exactly 4 immune persons? Now we do need to analyze this example. Now we have what we call, what we have here in 30% of a certain population are immune. We have 30%. They are immune against certain disease. And we pick a random sample. This sample was of size of 10 that selected from this population that has 30% immune. What's the probability that that it will contain exactly 4 immune persons? If we pick 10 samples, what's the probability to be 4 of them to be immune? And you know that previously that we have 30% in this large population are immune for a certain disease. Now, the solution, we'll take directly the equation. If x equal to 10 combination 4 multiplied by 0.7 to the power of 6 times 0.3 to the power of 4. Now, We do need to understand those values from where we get them. Now, the fx here, x here is 4. Since we are willing to obtain exactly 4 immune persons, 4. So from the equation, from the question right here, we have 4 immune persons. This is what we are willing to have. So if x will be 4, and we have 10 right here in the total number of the selected randomly samples, and 4 here is also the x that we are willing to have exactly 4 immune persons. 0.7 and 0.3 right here is the success and failure, as we discussed in our first part of this lecture. 0.3 is what we call the P. P here is the number of success, the percent of the success that has been taken from where? From the question. We have 30% of a certain population are immune for some disease, and the rest of them are not immune. So 1 minus 0.3 will yield 0.7. This is the Q. You don't need to write them down in your notes. 0.7 came from where? 1 minus 0.3. 0.3 is the 30% of the certain population that are immune for a certain disease. 1 minus 0.3 will yield 0.7. 0.7 is the Q, and 0.3 is the P. And 6 here is the combination. Combination of what? 0.7 to the power of 6. 6 from where we can get it? It is 10 minus 4. 10 selected samples minus they are willing to have exactly 4 immune persons. So n minus x, n is 10, x equal to 4, will yielded 6. And 0.4 is the x, as we discussed previously. This thing will yield, if we apply this equation and just only added the values that you are willing to have, this is the final answer will be 0.2001. And you can solve it by your hand, just to know that from where we get those numbers.